Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 7.3, day 1, entitled Double Angle and Half Angle Formulas. And what we're going to talk about today are the double angle formulas. We'll save the half angle formulas for the next section of notes. And the double angle formulas basically allow us to find the values of a trigonometric function at 2x from the value of x. So this is where you'll see the expression like sine of 2x or cosine of 2x. And the half angle formulas, when we talk about them in the next section of notes, they'll let us do that for the values of 1/2 x from just x. So the double angle formulas, there's one for each function. There's one for sine and cosine and tangent. And they basically come from the addition formulas that we've been working with. So in order to get sine of 2x, that means is that we have sine of x plus x. 1x plus 1x is 2x. Now this is our addition formula here, so I'm not going to just distribute the sine. So I have sine x plus sine x. That's not what that means. This means I have sine of x times the cosine of x plus the cosine of x times the sine of x. Now here, since the angles are the same, since it's x and x, I really have sine times cosine and sine times cosine, because I can multiply in any order. So I really have 2 times the sine of x times the cosine of x. So that's my double angle formula for sine. Now we have one for cosine as well, but I'm going to come back to it because it's a little more involved. So we're going to skip to tangent. And for tangent of 2x, this is where I would have the tangent of x plus x. So then I'm going to substitute these x's into the addition formula for tangent. So I'll have tangent of x plus tangent of x over 1 minus tangent x times tangent x. So in other words, this is going to be 2 tangent x in my numerator all over 1 minus tangent squared x in my denominator. Okay, so that'll be our equation or formula for the double angle of tangent. Now cosine really has 3. And again, we're going to start with the cosine of 2x. So this means I have cosine of x plus x. So 1x plus 1x is 2x. So then I'll have cosine of x times the cosine of x minus the sine of x times the sine of x. Now remember, when you multiply those together, you'll get cosine squared x minus sine squared x. So that's one version of the double angle formula for cosine. Now, I know what cosine squared is, and I know what sine squared is. So, if I substitute cosine squared x for 1 minus sine squared x, then I get another expression. Okay? I'm going to put the 1 minus the sine squared x into this spot for the cosine squared x. So then I have 1 minus sine squared x minus sine squared x. So that's going to be 1 minus 2 sine squared x. So that's another version of the formula that I could use. Or I could substitute something in for the sine squared x, because we know that sine squared x is the same as 1 minus cosine squared x. So if I substitute that in, then I would have the cosine squared x minus a 1 minus cosine squared x. So then when I simplified that, I would get cosine oops, I'd really have a -1 and then a plus. So I would actually have 2 cosine squared x minus 1. Okay, so that's the third version of the double angle formula for cosine. Okay, so there's all of those formulas written out nice and neat. They should be on your formula sheet as well. Remember, if you don't have a formula sheet, you can print one off the class website or you can get it in the classroom. Okay, so we have some examples then where we're just going to practice these. We're going to apply them. So in this example here, in example 2, we're going to kind of start off a little complicated here. And we're going to write cosine of 3x in terms of cosine of x. So we don't have any triple angle formulas. So we have a double angle formula, and then we have the cosine of x that we know. So I'm going to start by rewriting this as cosine of 2x plus x. Okay, so I'm breaking apart the 3x. Now that's an addition formula. Don't just distribute the cosine. Don't do that. That's an addition formula there because we're adding the angles together. So if I use my addition formula, I'll have cosine of 2x times cosine x minus sine of 2x times the sine of x. Okay? So now I have 2 double angles in there. So I have this cosine 2x, and then I also have this sine 2x. Now I want to write this in terms of cosine. So cosine 2x had 3 different versions, but the only version that has only cosines in it is the one where it's 2 cosine squared x. It has a -1, but that's okay. And then for my sine 2x, that really only has one option. So I'm going to have to write 2 sine x times cosine x. And then I'll have my other sine x that I'm going to bring down from up here. So I want this to be written in terms of cosine. So I'm pretty good here with my first term, but this second chunk of terms here, this is a problem because I have sines. Okay, so here I'm actually going to multiply. I'm going to distribute a little bit. This I'm going to do 2 sine squared x times the cosine of x. And then sine squared x, I know what that is. So that'll be 1 minus cosine squared x times cosine x. Okay, so I kind of finished that thought process there to get rid of the sines, and now I have my cosines in there. And I could even distribute the 2, so I'd have -2 let's see. Let me wait. Let me wait for that, and I'll come back to that in a second before I get too far ahead. Let me finish simplifying the left part of this first before I do that step where I distribute. Okay. So now here I have 2 cosine squared x minus 1 times cosine x. So here I'm going to distribute again. So when I have cosine squared x times cosine x, I'll get 2 cosine cubed x minus the cosine x. Okay. And basically I'm going to carry that down. Okay, so again, I'm just going to carry this down. That's really only one simplification that I can do. So I'm just going to carry it down again to the next line since we had like a 2-step simplification over here. Okay, so now I have to distribute And really, here I could distribute the 2 to the 1 and the cosine squared x, but I also have to multiply it by this cosine. Okay, so if I want to think of this as 2 times, I'm going to kind of distribute the cosine from behind there. We'll have cosine x and then minus cosine cubed x. Okay, so then again, this just gets carried down. I have another cosine cubed x over here. I know it's getting more and more complicated, but we're almost there. Okay, so now I can write my 2 cosine cubed x minus cosine x, and now I'll have a 2 cosine x, and then a plus 2 cosine cubed x. So now I finally have some like terms that I can combine together. So I have 4 of the cosine cubed x's, and then I have minus 3 cosine x. So that's a lot of work, but now I don't have a triple angle. I don't have a 3x. Now I just have individual x's. And granted, I'm cubing the cosine, but we'll find a way to deal with that in the upcoming notes. Okay, and again, it's all in terms of cosine. Cosine x, even though it's cubed, it's still cosine x. Okay, now these 2 examples, these are a little bit nicer because you actually get a numerical value for them. So if you look at example number 1 in your book, number 1 is similar to this example as well. So if you want to see more examples like this, look at example 1 in your book. And here again, we're given information about a specific trig function and a specific quadrant. So when you see this type of a situation, just like we did in the last chapter, you want to think of a little triangle, okay? And I'm in quadrant 3, so I would go over here to the 3rd quadrant and make my triangle. Now remember, to get into the 3rd quadrant, I have to go back and then I have to go down. So this is where my triangle is going to form, my right angle. Okay, so theta is over here then, or x, that angle measurement. So sine is going to be opposite over hypotenuse, so that means negative 3 and 5. So if you remember your Pythagorean triples, 3, 4, 5 is your Pythagorean triple. But the 4 has to be negative because we're in the 3rd quadrant, so I have to go back 4 and down 3 to get to that terminal point. Okay? So that's what that is telling you right there, is that we've got that triangle that we're going to use for our measurements. Okay? So in part A, I want to find sine 2x based off of the information that this triangle is telling me. So sine 2x, that's my double angle formula. So I'm going to rewrite that as 2 sine x and then cosine x. And now I can use the triangle to actually evaluate those. Okay? Sine x, which either they gave us or we can find in the triangle, is going to be negative 3/5. And then cosine x, okay, again, here's my angle. Cosine is going to be adjacent over hypotenuse, so that'll be negative 4/5. You can put the 2 over 1 if you want to. And then you just multiply across the top and across the bottom. So I'll have 24/25. Okay, so these problems are nice because you get an actual numerical answer. Now you have to do a little simplification up front. And for part B, we're going to have to do a little bit more simplification because I have cosine of 4x. So in the previous example, we had cosine of 3x. We split that up into 2x and 1x. So 4x, I'm going to split it up into 2x and 2x. So I have my 2 double angles. Okay, now again, this is an addition formula here. Don't just distribute the cosines. I have to use my addition formula. So I'll have cosine of 2x times cosine 2x minus sine 2x times sine 2x. So I'm using that addition formula. I'm not doing any distribution there. Okay. Now I'm going to do a little more simplification. I've got 2 of my cosine 2x's, and I know what cosine 2x is. Okay. If I look back here, cosine 2x, I've got some different options here. Now the problem, they gave me information about sine, so I'm going to use this second formula here, the 1 minus 2 sine squared x. Okay, so I'm going to substitute this cosine 2x with 1 minus 2 sine squared x. Now I have 2 of them. I have cosine 2x times cosine 2x, so that's like cosine 2x squared. So I'll just square that. And then I have sine 2x and sine 2x. Now for sine 2x, there was only one way to write that double angle formula, 2 sine x cosine x. So I'm going to have 2 sine x cosine x. But again, I have 2 of them, so I'm going to square it because I have 2 sine 2x's up here. Okay, so now that it's in terms of sine and cosine, and it's just sine x and cosine x, I can substitute in this information. Now, even though this is sine squared x, I can still find sine of x and then square it. So I'm going to have 1 minus 2 times, now sine of x was negative 3 over 5, and I have to square it because it was sine squared, and then that whole expression will be squared, that whole value will be squared. Okay, and then I'll have 2 times the sine of x, which was negative 3 over 5, and then the cosine of x, we had it over here, or we could find it in our triangle, was negative 4 over 5. And again, I'm going to square that whole product when I find it. Okay. So now inside my first set of parentheses here, I'd have to do the negative 3 over 5 squared, multiply it by 2, get an answer, and then subtract that from 1. When I do that, I get 7 over 25 squared. So I still haven't done this outer exponent. In my second set of parentheses, you could just multiply 2 times negative 3 over 5 times negative 4 over 5. That's what we did over here as well. So I'm going to have 24 over 5, I'm sorry, 25 squared. So now it's a calculator problem. Take 7 over 25, square it, and subtract 24 over 25 squared. And you should get negative 527 over 625. So you get a big fraction, but at least you get an answer. You get a numerical answer. And part B has a lot more simplification that we need to do than part A does. But if you can follow through part B and follow all those steps, then you're practicing at a high level of preparation, and you'll be prepared for a quiz and a test. Okay, so that was just extra room if we needed it. Okay, now we're also going to talk about the lowering powers, okay? Because if we have cosine of 2x, we really write it as cosine squared. So that shows that cosine of 2x is a polynomial of degree 2. And we can do that for any number. So we could do that for cosine 3x, cosine 4x, cosine 5x. We could write it as a polynomial of a certain degree in terms of cosine or sine or tangent. So that's where we get these half angle formulas. Well, proof of the lowering powers formula. These are the lowering powers formulas. These aren't exactly the half angles yet. So this title is more just the title of the whole chapter, okay? But these are going to be the lowering powers formulas. So this is how you can rewrite sine squared x as something without a squared, or cosine squared x as something without a squared. Okay? And they connect back to our double angle formulas. So there's a lot of going back and forth between these different types of formulas. Okay, so I'm going to start for the sine squared x. I'm going to start with, I know it seems funny, but the double angle formula for cosine. So I have cosine of 2x, and I'm going to start with the one that had the sine in it, which was 1 minus 2 sine squared x. Okay, now if I'm trying to solve this for sine squared x, I would subtract the 1 over. So I would have cosine 2x minus 1 at negative 2 sine squared x. Okay, then I would divide everything by negative 2. So then I will have sine squared x equals, now it's going to be a negative cosine 2x over 2, and then a positive 1/2. So the way your book writes that is they put the positive term first. So they do 1 minus cosine 2x, and they put it all over 2. Okay, so now I have a formula that helps me get rid of that squared, that sine squared. But I have to use the double angle formula for cosine. So again, there's an interconnectivity between all these formulas. The cosine squared x, if I want to rewrite that, again, I'm going to start with the double angle formula for cosine, and I'm going to use the double angle formula that has the cosine in it. So that's 2 cosine squared x. So again, I'm going to solve this for cosine squared of x. So I would add the 1. So I'll have cosine 2x plus 1. And then I would divide by 2. So I'm kind of running out of room here, but we're going to divide both sides by 2. So I'll get cosine squared x equals. Now this one you can write it either way because it's not positive or negative. But again, your book likes to put the whole number first. So 1 plus cosine 2x all over 2. So these, again, power reducing or power lowering formulas both rely on the cosine formula, the double angle for cosine, and they both have cosines in them. But it's a formula that we can use to get rid of that squared. And then there's one for tangent as well. There we go. The one for tangent, basically, we're going to just rewrite tangent. We're going to make it sine squared x over cosine squared x. Now, we just solved the formulas for sine squared x and cosine squared x. Here's what sine squared x is, and here's what cosine squared x is. So basically, I'm just going to substitute those in to this expression. So I'll have 1 minus cosine 2x over 2 all over 1 plus cosine 2x over 2. Now I can't have a fraction and a fraction, so I have to multiply by my reciprocal. Okay. So the stuff in the denominator here, it's all going to cancel. The 2's will cancel up here. And I end up with 1 minus cosine 2x over 1 plus cosine 2x. So that's where those formulas come from. The formulas for lowering the power. And again, that's just getting rid of a squared. If you didn't want an expression that had sine squared or cosine squared or tangent squared, this is the equation or the formula you'd have to use to get that value. Okay, so let's do one last example here where we're dealing with these lowering power formulas. And it says express sine squared x and cosine squared x in terms of the first power of cosine. So that means we want to write it in terms of just cosine x, cosine to the first. Okay, so what we're going to have to do then is we're going to have to rewrite the sine squared x, which we know is 1 minus cosine 2x over 2. And then the cosine squared x, I can rewrite that as well in terms of the cosine. That was the 1 plus cosine 2x over 2. Now, I can multiply those out. So I'm basically going to FOIL in my numerator here. So 1 times 1 will be 1. Then I'll have plus cosine 2x. And then I'll have a minus cosine 2x. So they're going to cancel. And then I'll have a minus cosine squared 2x, because I'll have a cosine 2x times a cosine 2x. So that's cosine squared 2x all over 4. Now, this doesn't really help me get rid of the exponent, because I rewrote it without exponents, and then when I FOILed to simplify it, I got another exponent. But it does help me a little bit, because I could break this apart into 2 terms. So I could have the 1/4 and then the cosine squared 2x over 4. So now I have this cosine squared of 2x, so I have to lower my powers again so I can get rid of that squared. Okay. Now that's just like what I did up here with the cosine squared x, except now I have cosine squared 2x. So instead of having a 2x here, I'll have a 4x. Since this angle is doubled here, it's going to double in my formula for my lowering. So I'll leave the 1/4. And then I'm going to have, oops, let me fix that parenthesis, I made it a little big. In my numerator now, I'm going to have 1 plus cosine 4x over 2, and this is still going to be all over 4. So here's where your algebra skills are going to come in handy now. Okay? Again, I've gotten rid of that power. Now granted, I have a cosine 4x, but that's okay. When we're dealing with our power lowering, we often increase that actual angle. So I've got a multiple of 4 here. That's okay. But I also have this 1/2 that I have to break apart, and then this cosine 4x over 2 that I have to break apart. And I have to divide both of them by 4. Okay? So I'll have the 1/4 out front still, minus, and then I'll have a 1/2, and then I'll have a cosine 4x over 2, and it's still all going to be over 4. So then, let me do some coloring in here. I'm going to split this numerator of this complex fraction into 2 parts. I'm going to do this part, and then I'm going to do this part. Okay? So I will have still the 1/4 out front, and then if I have 1/2 divided by 4, that's going to be 1/8. So minus 1/8, and I'll be able to combine those together in a moment. And then here I have this 1/2 divided by 4. So this denominator was a 2, so it's kind of like 1/2 divided by 4 is still an 1/8. So I'm just going to write this as, now I'm really distributing the negative here too as well. So I'll have minus cosine 4x over 8. So then the only thing I have left to simplify there is to combine these like terms. So I'll write my answer up above here. So 1/4 minus 1/8, that's going to be 1/8 minus cosine 4x over 8. Now you can leave it like that. Your book will take out the 1/8 as a GCF. So they'll write it 1/8 of 1 minus cosine 4x. Okay, so if you see that in the back of the book, it's the same thing as this fraction here. Okay, so this is a good problem to take a look at because you have to use the lowering powers twice. Okay. Most of the problems you'll just have to do it once, but this is just a good example to show you what you do if you need to do it twice. And that was extra room if we needed it, but I smushed it all onto the one slide. So here is your set of practice problems. Again, they're all odds, so you can check them in the back of the book. They're all worked out in the binder as well in the classroom. And if you have any questions, come on in and see me before school.